In this two-part video series, we bring to you the top 15 mathematical discoveries and inventions by mathematicians of
Bharat
that have revolutionized not only mathematics, but science, technology, and everyday life forever. We have ranked them and presented them in the increasing order of significance. These have been created or developed by Indians much before these were popularized by the Western mathematicians, getting the undeserved credit in the process for their creation. This is the second and concluding part, featuring rankings from number 8 to number 1 right at top. You can find the link to the first part video, published earlier, and featuring rankings from 15 to 9 in the description below. The name trigonometry is itself derived from the Sanskrit word trigonometry, meaning measurement of triangles. Indian astronomer cum mathematicians have contributed significantly to the evolution of modern trigonometry. They invented trigonometry to observe the planets and stars more precisely. The discovery and development of trigonometric functions like sine and versine originated in ancient India. The earliest known definitions of sine, called ja, and versine, called utkrama ja, appear in Indian astronomical texts from the 4th and 5th centuries CE, such as the Surya Siddhanta. These texts contain the earliest surviving tables of sine and versine values with significant accuracy. The Indian mathematicians also defined related functions including cosine, called ko-ja. These trigonometric concepts and tools revolutionized astronomy and navigation and became the basis for modern trigonometry. Aryabhatta I used linear interpolation for calculating trigonometric functions. Bhaskara I had an analytical formula for sine x. Brahmagupta used second-order interpolation. Varaha Mihira discovered identities like sine squared x plus cos squared x is equal to 1. Madhava made pioneering contributions to the infinite series expansions for sine, cosine, tangent, and arctangent functions, as already explained in part 1 of this two-part video series. But discovery of trigonometry is wrongly attributed to the Greek astronomer and mathematician Hipparchus, who lived in the 2nd century BCE. He is supposed to have constructed tables of length of a chord in a circle, in steps of 15 degrees of the extended angle, said to have been refined later into steps of half a degree by the Alexandrian astronomer and mathematician Ptolemy. But none of these tables have survived passage of time to lend credence to these claims, which are just hearsay. But chord geometry is not trigonometry. Calling Hipparchus the father of trigonometry is absolutely ridiculous. Thus, the trigonometric concepts and terminology were first systematically discovered and developed by Indian mathematicians during the classical period of Indian astronomy and transmitted from India to the Arab region, and then to Europe in the 12th century CE, when the sign notation and concept entered Western mathematics, with sinus used in Latin. The term cosinus for the cosine function was standardized in the 17th century, with usage by William Oughtred of Renaissance fame and others around 1600s. We are all very familiar with the Pythagoras theorem in geometry, possibly learnt in secondary school, or middle school, as it is called now. It is attributed to the Greek philosopher-mathematician Pythagoras, who lived from 570 to 490 BCE. But actually it was invented by Maharishi Bodhayana, who was both a great expert in Vedic rituals and mathematics. His treatise, Bodhayana Sulba Sutra, dated around 800 BCE, actually lays out this sutram or rule in this Sanskrit verse. Meaning of this verse: areas produced separately by the length and breadth of rectangle together equal area produced by diagonal. Thus, the credit for this theorem was wrongly given to Pythagoras 270 years after Maharishi Bodhayana discovered and documented it. Therefore, we should rename it justly and correctly as Bodhayana theorem. Maharishi Bodhayana is also recognized as one of the earliest to attempt calculating the value of pi in his work. The Bodhayana Shulba Sutra of 800 BCE which provides a construction implying the value of pi approximately as 3.125, derived from the rule that the circumference of a circle is 3 times the diameter plus 1/8 of the diameter. That is, 25 divided by 8 or 3.125. Baudayana's approximation for value of pi, while simple, is the earliest recorded in the history of mathematics. But credit for earliest approximation of pi is given to Archimedes, the Greek scholar of several disciplines, who 550 years later used a method involving inscribed and circumscribed polygons to estimate pi. He showed that pi is greater than 223 divided by 71, which is about 3.1408, and less than 22 divided by 7, that is, about 3.1429. Later, Aryabhata I, in his work Aryabhatiya of 499 CE, improved this value to 3.1416. He gives his method in this Sanskrit verse, which translates to add 4 to 100, multiply by 8, and then add 60, 2000. For a circle with a diameter of 20,000, this gives the approximate circumference. Its interpretation: the circumference of a circle of diameter of 20,000 is 62,832. Therefore, the implied value for pi is 62,832 divided by 20,000 equals 3.1416. Its significance: this value is accurate to 4 decimal places and is remarkably close to the true modern value 3.141592, and so on, making it one of the most precise approximations of pi from the ancient world, centuries ahead of its time. Aryabhata also indicated that this was an approximation, using the term asana, suggesting his awareness that pi is an irrational number. The binary number system is a positional numeral system, meaning that it employs only 2 symbols or digits, 0 and 1, using base 2. Each digit in a binary number is called a bit, and the value of the binary number is computed as the sum of powers of 2 corresponding to the positions of the bits. Binary arithmetic is simpler than decimal arithmetic, requiring fewer computations for addition and multiplication. This system is fundamental in computing and digital electronics because it matches the two-state nature of digital circuits, where 0 and 1 can represent off and on states, respectively. Acharya Pingala, an ancient Indian prosodist and mathematician who lived around the 3rd century BCE, is credited with the earliest known description and use of the binary number system. While studying Sanskrit poetic meters, or chanda, Pingala observed the rhythmic patterns created by short, or lagu, and long, or guru syllables in verses. He used these 2 syllable types as a precursor to the binary digits 0 and 1, respectively. Pingala's work in his treatise, the Chanda Shastra, involves systematically listing all possible combinations of laghu and guru syllables in meters, effectively creating a binary counting system. He generated all possible patterns of these syllables and devised algorithms to index and count them, corresponding to powers of 2. Substituting digit 1 for lagu and digit 0 for guru, we get Pingala's binary system, which is amazingly an exact mirror image of modern binary system. Pingala's work represents the earliest attempt to enumerate possibilities with just 2 states. His binary system predates the formal development of binary arithmetic by the German mathematician Gottfried Leibniz in the 17th century CE by over 1,500 years. But the Western world unjustly credits Leibniz with invention of binary system. Thus, Pingala's invention of the binary system was rooted in linguistic and poetic analysis, but served as a foundational step toward mathematical and computational theory, demonstrating one of India's significant ancient contributions to mathematics. We hope you are enjoying this video, brought to you by the Unknown India channel that tells you all about India, that is Bharat, that you did not know. Please like this video, share it with your contacts, subscribe to the channel if not done already, and hit the bell icon to be notified of new videos. The quest of Vedic Indians to invent geometry arose from the need to construct ritual fire altars accurately. During Rig Vedic times, dated around 4000 to 4500 BCE, that is 6000 to 6500 years ago. Fire altars in 3 geometric shapes were known, namely the square, circle, and semicircle, as per the Rig Veda verse 02364. We have a separate video on the age of the Rig Veda, as per link given in description below. These 3 types of altars have also been excavated in several Harappan sites, including Kalibangan in Rajasthan, and are dated to the early Harappan period of 3200 to 2600 BCE, that is, over 5200 to 4600 years ago. In Lothal, Gujarat, fire altars have been found in both private houses and in public places. These are dated to the mature Harappan period of 2600 to 1900 BCE, or 4600 to 3900 years ago. However, the oldest use of accurately constructed geometric shapes like circle is attributed to Mesopotamians around 3350 BCE for invention of the wheel, and that of triangles to Egyptians around 2500 BCE for construction of pyramids. Indian rishis who wanted to understand the universe and Indian astronomers who wanted to measure cosmic distances and dimensions of stars and planets needed a system of very large numbers. So they created a system of very large numbers in powers of 10. These were also useful later in large public systems, trade, commerce, etc. Verse number 20 in Prapathaka or chapter 2 of Kanda, or book 7 of the Theorem Samhita of Krishna Yajurveda, lists all these large numbers with their Sanskrit names of all the powers of 10, right up to 10 to power of 12. The Theorem Samhita is 4,375 years old. We have a video on its age, as per link in the description below. The largest named number for the ancient Greeks, 4,000 years ago, was a myriad, which was 10,000. Of course, Archimedes did evolve a system of large numbers, but that was much later in 3rd century BCE. Even the ancient Romans of those times could count only up to 1,000,000. Thus, the Indians had devised a number system for very large numbers in powers of 10 over 4,375 years ago, much before any other civilization. It was in India that the decimal-based numbers started getting used first, even for day-to-day purposes. And we all know how important the decimal system is in developing modern mathematics, science, computers, software, digital platforms, and products, AI, etc. Apart from mentioning the primary numbers from 1 to 9, 10, and its multiples from 20 to 100 are also mentioned in this verse of Rig Veda. Its meaning, O Indra, come thou hither, having harnessed thy car with 20, 30, 40 horses. Come thou with 50 well-trained coursers, and draw 60 or 70 to drink the Soma. And as per another Rig Veda verse, the Maruth gods were prayed for, 3 times 60 for benefits, and as per yet another Rig Veda verse, Indra was prayed for horses thrice 7 times 70. This shows the popular day-to-day use of the decimal system in ancient Hindu world from the time of the Rig Veda, that is to say, 6,000 to 6,500 years ago. Link to our video on Age of Rig Veda is given in description below. The 10 verses in Prapathaka, or chapter 2 of Kanda, or book 7 of the Theorem Samhita of Krishna Yajurveda, are completely devoted to numbers. The Theorem Samhita is 4,375 years old. We have a video on its age, as per link in the description below. Thus, the Vedic Indians knew and used the decimal number system even as early as 6,500 years ago. It was refined and developed further by the great Indian mathematician Brahmagupta. Brahmagupta's texts were translated into Arabic by Muhammad al-Fazari, an astronomer and mathematician, under the names Sindhind and Arakand, towards late 8th century CE. An immediate outcome was the spread of the decimal number system used in the texts. The mathematician al-Khwarizmi, who lived from 800 to 850 CE, wrote a text called Al-Jam wal Tafriq Bihisal al-Hind, that is, addition and subtraction in Indian arithmetic, which was translated into Latin in the 13th century as Algorithmi de numero indorum. Through these texts, the decimal number system and Brahmagupta's algorithms for arithmetic have spread throughout the world. But the Indian decimal number system was very wrongly attributed to Arabs. Al-Biruni, the Iranian scholar who was proficient in several languages and sciences, traveled to India. He later wrote in 1030 CE in his book Tariq al-Hind, or Chronicles of India. The numeral signs which we use are derived from the finest forms of the Hindu signs. Despite all this, the West unjustly calls the Hindu numerals as Arabic numerals. At the top slot of number 1 is the concept of zero, which is the most fundamental concept that has revolutionized all branches of mathematics and computation. It has 3 connotations, namely, 1. As a unique number denoting nothingness or emptiness, 2. As a placeholder which, along with other numbers, is of great value, and 3. Also representing one of the 2 states in modern binary system. The oldest indirect reference to zero is in the Nasadiya Sukta of Rig Veda, which philosophically explores the notion of nothingness or non-existence as a unique state before creation, preceding manifest existence. Another verse of Rig Veda refers to shunya in the context of a lack or nullity. In the Vedic worldview, shunya or zero was viewed as a potential or void from which creation arises. Rig Veda is dated around 4000 to 4500 BCE, or 6000 to 6500 years ago. And we have a separate video on its dating, as per link given in description of this video. But Western scholars are wrongly crediting the Sumerian civilization of Mesopotamia as the first to use concept of zero, around 3000 BCE. Acharya Pingala, the noted Sanskrit prosodist and mathematician, also recognized it as a unique number in his Chanda Shastra, written around 250 BCE. So, we are compelled to ask several questions. Why was due credit denied to Indian mathematicians? Was it because of ignorance, pride, prejudice, or some other reason? Western intellectuals need to reflect on this. But perhaps the problem lies with Indians too. Have they taken up these cases strongly in international fora? No. What about the common folk in India? Are they even aware of all this? Even those who are aware, are they proud of these discoveries and inventions? Are they passing on the information down to generations? No. A lot of introspection is needed by Indians themselves.